for joining us. I have with me Ryan Houston and Daniel Tam, two of my coworkers here at Optigo, and three of us spend a lot of time sitting together poring over Wireshark files in Visual BACnet, trying to figure out what the heck is going on. And so I'm really excited to spend some time troubleshooting with them today and show you exactly what we do on a daily basis here at Optigo. For a little bit of background, Daniel is one of our developers here. He's our sort of resident BACnet expert and has really been involved in developing all of the diagnostic checks and a lot of how Visual BACnet works. And Ryan has 15 years of field experience, previously with Delta Controls. He's been with us for about a year now, being our strategic solutions provider and helping people use Visual BACnet in the field. So we've got the right team here today. Okay, enough about me talking. Ryan and Daniel, do you guys want to take it away with our first file?
We'll take it away. And we can see the screen and we're good to go?
Yeah, so this first file, I told you guys to take it away and now I'm going to take it away. This first file is from a hospital. It was submitted to us by Phil. So I'm hoping that Phil is online and can actually tell us a little bit about what was going on. So I'm going to put him on the spot, and Phil, I'm going to unmute you. Phil?
Hello.
Hi. Can you tell us a little bit about what was going on in the hospital and why you thought you needed a file? Let me just fix something.
Well, I've been involved there for a couple of years now and just trying to get the existing network cleaned up. It's about half, well not half, about a third V2 still and 2/3 V3. We just recently implemented a couple of new VLANs to get 2 new buildings onto the network. So I see that the network health has gone down a bit recently, and I'm not too sure why. It was a little higher over the last few months. But yeah, just kind of, you know, I've been poking around with this for a while and trying to do a little sleuthing, and there's a lot of helpful information here. I hope I can find more.
Great. I like to hear that you're being proactive. Okay, so with that, Brian, Daniel, what's the first thing that you're going to do when you take a look at this file?
Well, the number one thing is a health score. I mean, if it's 100%, we're done, we can go home, right? That would be great. But never actually seen a network at 100% yet, unless there's no BACnet data in it. So we know it's a good protocol, but it's tough sometimes. So the first things I look for is I always start at the top, right? How long is this thing? Is it 5 minutes? Is it an hour? Is it 2.5 hours? It really makes a difference. 5-minute capture will give you some detail, but not everything. 2.5 hour capture will give you a lot of information. We typically say an hour is enough. So it's great. There's lots of information here. That's good. The next thing we look for is what's the breakdown of all the traffic, right? There's a lot of non-BACnet traffic on this network, and there's a little bit of a straight BACnet and about 40% of broadcast traffic. 40% is pretty high in the broadcast traffic, so that would be an area of interest right away to go look for. And then we start going down the list. We scroll up a bit and we start looking at the stats. And here, I typically look for how many devices you have kicking around in this network and how many isolated networks.
So, Phil, can I ask, does 2,200 devices sound accurate? That's about how many devices you have?
Yeah.
Okay. Always a good thing to check, because sometimes it seems totally off, and that's a good flag to start to begin with.
Right, for sure. So the next thing that's really intriguing about this file is when you see in the traffic rate here, you've got a repeating, something's happening repeating. But the interesting part here is it's not in BACnet. As if we isolate BACnet only, this doesn't look too bad. But when you start looking at the non-BACnet traffic, well, something's happening. So normally this traffic would just sit at a normal threshold rate because you have converged networks or there's other type of stuff that happens, not a big deal, but it's the recurring rate that's interesting to us. Now, this may not be a big deal, and it may be just part of the application I assume because, Phil, you are using Delta controllers, this is probably an IntelliWeb server at this point.
There is
the
an
way you can
IntelliWeb,
tell,
yes.
there is a server, okay. So the way you can tell from,
There's 2 right now.
okay. Oh, excuse me. The way you can tell is you go into the peak non-BACnet burst traffic, and this is a little tidbit here that we have. It's not BACnet specific, but it does show us some information about what that peak, what those cyclical traffic is looking at. And when it comes up here,
So a lot of data in the file, or non-BACnet data. This is useful because I've had people say, oh, there's only BACnet traffic here. And you go, well, no, that's not true because I can see all of this other traffic. And they say, well, what is it? And so you can go in here and say, oh, it's this type of traffic. And they can go back to IT or their own team and say, okay, it's these types of traffic.
so the interesting part here is that it's the same source, right? Same source, same destination. So odds are, we know it's the Delta controls. It's probably the IntelliWeb server. It's probably going to some BBMD or something on site, and it's doing some proprietary information. So if we take a look further into the Wireshark details, we can see there's standard TCP traffic and there's some SSL traffic. And that's as far as we can look because we don't troubleshoot that side of the network. But our suspicion would be that the server is doing some standard updates, maybe it's doing time syncs, or it's checking on controllers, or it's checking on the network on a periodic time basis. If it was too much, then you could potentially turn it down or slow it down in the application. But for the most part, it's probably fine, and it's not, obviously this part doesn't affect your network, but it does affect how much traffic is coming out of that network pipe.
Okay.
So that's the first start. So if you knew about that and what it's doing, then no big deal. So then we start moving our way down to the next check. Now, you can use this side, this diagnostic check side, because each one of these different checks will be open and ready to view if there's a failed check. But there's a secret little button here in the network health score. And when you click on that, this gives you the same list, but it's reorganized in order of critical functionality to the site. Things like circular networks, not good, fix those first. So we allow you to really focus on what the actual issue is and break down. Right here we can see we have 7 unresponsive routers, right?
So let's tackle that first.
So when we say unresponsive, we don't mean offline because we don't actually know. What we know is we look for we said who is router and nobody answered our question. So that's why these are showing up. So you can click on the line and it'll spit out the answer. So these guys at the bottom, right, for 49999, he only sent out 1 request and he got a response back. Probably not a big deal, might have just missed it in the traffic. But this guy is more interesting, right? 50620, 176 packets. Every time he asks, he doesn't get a response.
Daniel, did you have something to add there?
Right. So it's actually so maybe one device or a couple of other devices that's asking for network 50620, and of all these requests that are sent to find a router to this network, none of them got reply. So it's either the network doesn't exist or the router that's responsible for this network is not responding.
Right. So beware of phantom networks.
Right, so this could be, it's possible it's leftover graphics or leftover programming, asking for something that isn't really there, or it's truly offline. Or there's a lot of cases too that we've seen where the router is also doing programming or serving up some other details, and it simply can't respond to these requests. But when we dig into this a little bit, we can...
Actually, I just muted Phil, but I'm muting him again. Phil, do you know if network 50620 is a network that should exist on your system?
I'm actually just online. I'm looking at it. I'm going to track it down.
Okay, no worries. Take your time.
Well, Well, according to our system here, it doesn't exist, so it might be hard to find.
So hopefully, we always say when you're troubleshooting a file, have your device list, have your network list available, and then you can cross-reference and say 50620 shouldn't exist. I don't know why everyone's talking to it, and then you can go and troubleshoot devices that are talking to it.
So the interesting part about this, what happens is when you click on it, now we see that there's 5 sources here. 5 controllers are asking for that network. But now you can actually take the data by the Ethernet or MAC address, put it into your system, and see what's going on with that data. Why does it keep asking for that network? So now very quickly we've said, oh, I have an offline or an unresponsive router, and I know the sources that are asking for that network. Let's go look at the source. Right, and then right away, you can go onto your server or whatever you have and start seeing what's going on. Not a lot of information in here at this point, but at least it gives you a good start. So now you can dig into those controllers, look at where all the data transfer is, and see why this network keeps coming up. Unfortunately, the way it is in the world is as we decommission different controllers in different areas of the building, then things get missed, and that's just the nature of the beast. But it does add unnecessary traffic to your network, and the longer that building's around, the more of this you have, and the more just plugged up with stuff it gets.
Yeah, I love those phantom. One of the things that BACnet often finds first on a network is a bunch of phantom devices, networks, things that used to be there but aren't anymore, but someone's still talking to them, unnecessary traffic. So definitely be aware of that. So
that would be the first path. Find that unresponsive router, see what's going on. Once those guys come back online, this unresponsive devices, this score should go down. Because if the router's not there, then the devices underneath it are not there, so on and so forth. So I don't even look at the unresponsive devices until the unresponsive routers is clear.
So 6 to 7 routers, and then run another capture, throw it in here, and hopefully you'll have 0 unresponsive routers and 0 unresponsive devices. But then if you have unresponsive devices, then we can start digging into those.
Now, as we keep going down the file, I see some interesting things. There's a couple error responses, but there's 39% in missing ACKs. That's interesting as well. So once you dive into this, you've got a source here and a destination. Do you have Carpentry on the site, Phil?
I just muted him.
You just muted Phil?
Well, I could hear you back. All right, Phil, you're unmuted.
Yes, there's a Carpentry
on the site?
Yes.
Okay.
And Phil, and you just messaged me, but so everyone knows, you weren't able to find that network in your records, correct?
No, it's not there. That's right.
Okay. So you'll have to go and find those sources that are talking to that network and figure out why they're talking to it and see if it's a real network.
Right.
Simple, right?
Easy.
We've only been here for 10 minutes.
It's pretty interesting.
Yeah, so as you go down, the missing ACKs is interesting, I always find. This one is obviously one of your copper cubes talking to another one of the controllers. But the interesting part when we look at that is it's asking for a lot of read property multiples, which makes sense. For those of you that don't know, the copper cube is an archiving solution. It's a hardware appliance that you put on site, and it archives all the information. So it's going to ask for other controllers out there and pull their information back. But what's happening is, if you look into the Wireshark detail and look at the application, it's trying to find the device. Why is it the missing actor?
Because that's the request and there's no response to that request.
Right.
So it's asking for a whole bunch of properties.
So it's asking for all this information. So this is the part that probably failed, right? It's asking for the vendor proprietary value, and it doesn't give it, or asking for the name. So there's a bunch of, when you automatically, we see this a lot in analytic services, where, or even third-party gateways, they just automatically ask for the information, but the device you're asking it from doesn't support the property. So it doesn't engage, and it doesn't set or it trips the flag. So there's an awful lot of this happening in the network. Should be easy to fix. You can just specify that that doesn't exist and stop asking for it. But again, it's more traffic because every time you send the acknowledgement out and you don't get a response, then errors happen and all of this stuff moves along. So that one's pretty easy to see. We see it a lot in definitely third party. There's a couple problems in the checksum error. This is checksum's normally either something busy or a hardware fault. This is in the, there's not too much here.
Maybe non-BACnet.
It's a bit in the non-BACnet though. Just some standard ARP requests to TCP. It could be a sign of a switch failing potentially. Sometimes it could be the sign of a loose connection.
And this is always coming from the same source.
Right, it's all coming from the exact same location. So might be an idea. It's obviously broadcasting out, but it could be an indication of something happening on the site. You could either go and try and re-terminate the connections or just keep an eye on it to see if it gets worse. So as we go down, the max network succeeded. This is an interesting check. It's not applicable to everyone. What it means is if you've got old routing hardware on your site, because there's 133 networks, it has to go through a router somewhere at some point, right? Through a BBMD or some higher level router as your tree topology moves up. Even on a flat network, you have to engage into the network somewhere. So most systems could handle 100 or 150 networks. Some can handle up to 400 or 600 networks. It's always an idea to say, how many am I handling and can my existing router hardware handle it? If you just go and add another couple of buildings and haven't changed any of that infrastructure, this will trip, and then you could go back into our unresponsive router problem, right? Because you've just put a big load on it that it can't actually take.
Check out the global who is. 2,369 global who is in, what did we say, 2 hours?
2.5 hours.
2.5 hours.
So this is a bit interesting, but down here is a score check. They're not as critical, they're more warnings to you, right? Let's start at the top before we get to the global who is.
Right.
We get all excited. There's a few global private transfers. That's just a non-BACnet way of sending some data up. So every vendor is going to have their own proprietary way. The BACnet broadcast traffic, on average, a good system should be in the 10 to 15 mark. So you're on squeeze high. But we've seen this upwards of 70 or 90 packets per second in broadcast, which is not good.
This one really depends on your network. If you're a small network, you should be in the 5 range. If you're a huge network, this isn't so bad. So this one scales a bit with the size of your site. But if you're noticing problems, there's a good chance that a ton of broadcast traffic is impacting that.
Yeah. So everything else looks pretty good. The who is an interesting number. And what happens here in the who is different vendors' systems go and troll the network for new devices every so often. So those are done in a who is. So segmented who is are also in this check along with the global who is, right? Just for reference, we are actually looking at separating those. But for now, that's what this means. So I happen to know that the Delta system does go out on a periodic basis to search and make sure the controllers that it knows about are online. And that's what a lot of this is. And you're going to have this twice because you said there's, I believe the Copper Tree system will do that, and you've got 2 IntelliWeb servers. So all of that's being impacted here in the system.
Can you click on that and we can see who's sending those?
Sure can.
All right.
So these are all the sources of who's sending it, which is quite a bit.
So probably not great that you have 18 different devices that are sending global who is on your network. That first one failed. Do you know what it is? Device 10014.
Do you have any old V3 systems out there? Like the OrcaView? Do you have any OrcaView systems?
Yeah, there's about a dozen OrcaView workstations on the network, and that's probably one of them.
Right. So if you say there's a dozen, we're showing 18 here, so that's 12 away, 2 IntelliWeb servers, a couple copper cubes. It's pretty much your list, right?
Yeah.
So the
Yeah.
fact that the top two are sending 626 in 2.5 hours is a lot of traffic to be on your system.
Yeah.
So it's always good to look at the time that these are happening. So these are happening every 8.
But these may be segmented. Yeah.
Yeah, it's segmented.
seconds.
So 0 to 201, 203 to 794. So what we are looking here is within this chunk is probably one whole entire range of fluids, and it's at 1025. So
it's not too bad. It's going to take about 5 to 10 minutes.
so and we see the next one, the next big jump was at 1041. So
Right.
maybe about 15 minutes. 15
Yeah.
minutes.
And so by going into the frame information and expanding the ATDU, you were able to see the device incident range that it was looking for and tell that it wasn't fully global, it was segmented.
Yeah.
Cool.
Then if you have a non-segmented one, you'll be able to see the time interval more clearly.
Okay. So, I mean, the fact that it's segmented at least means not fully overloading your network by sending those, but it might be good to see if it can be less than every 15 minutes and expand it to every half hour. Does it need to be sending you this often? Hopefully not. And you can save yourself a lot of time.
Mm-hmm.
The next piece is the longest response time.
11 seconds.
That one's pretty bad.
Not ideal.
Not ideal.
Less than ideal, I would call 11 seconds.
The cool thing about longest response time is we actually know where the source and destination is. So right here, device 802, and it's going to device 30,200, and it's taking that long. So this is where we have the information. We can tell you a bit. You have the map. You can tell us what it's going through. It's asking for read data, and it's taking a long time to get it. So when your customers, and they're all out there, complain that the graphics are slow, take a look into this one. Because if you have a graphics refresh of 5 to 10 seconds, plus the 11 seconds to actually get the data, you can be 20 plus seconds before that data refreshes.
Wow.
Yeah.
But this is an easy one because you know the 2 controllers that are in play, and you can look on your map to see what the route is between them and go through start narrowing it down and see what happens. Now, for those of you that don't know, we can actually use this trick. You can always set a read request from between any network or segment from controller to controller. So if your customer is complaining of slow graphics from a specific system, put a read request on it. Let's time it, because we'll time it automatically and you can see what the issue is. You can put it from the server to the end device, you can put it from controller to controller, and it'll show up here, and we can just figure it out. At least you could eliminate it. Very common in lighting. Right, I push the switch and I wait 5 seconds for the lights to turn on. So it's an extra trick you can use to figure out some additional issues. And I think that's the end of this file.
Okay, so in summary, we would recommend that Phil go out and check those unresponsive routers, look at the sources that are trying to talk to that all of those different networks. If the networks exist or should exist, check what that router is doing, see if it's offline or for some reason it's unresponsive. If that network doesn't necessarily exist or you're not sure, check with the sources, see who they're trying to talk to, maybe reconfigure to talk to an actual network. And then maybe look into some of that broadcast traffic and definitely those read requests.
Perfect. Easy one.